So in this video, we are looking at converting z-scores into actual scores. And how these questions are going to look is that they're going to require us to work backwards. So this involves us trying to find a score given a z-score, a mean, and a standard deviation. So when we rearrange the z-score formula, this one here, and make x the subject, because we're trying to find the score, what we would do is to make it the subject, we want to kind of systematically work from this right-hand side. So we would first, since it's dividing by s, we would multiply by s. So multiply z by s, and then we would add the mean to both sides to get rid of it from the left-hand side. So what we would get by making the score the subject of the formula is something like this. This is the expression for finding a score when given the mean, standard deviation, and z-score. But we will look at how this will work in this first example. Now it's saying in a normal distribution, the mean was 30, standard deviation was 3.5, and Blake achieved a standardized score of 2. Anytime it says a standardized score, it means z-score, okay? So it's saying calculate Blake's actual score, so what his mark was, what his score was, first using the formula that they've just given us here, okay? So in part A, we're going to say x equals 2, the mean, which is 30, plus the z-score, 2 times 3.5. Okay, so we do this, and that gives us 37. Now, what we're going to do for the next one is we're going to substitute into this formula, but then just work backwards to systematically solve the equation. And we should get the same answer because this thing here is just this formula rearranged. Now, what I'm going to say is I'm going to substitute in everything I know. So we know that z is 2 equals to x minus 30 over 3.5. So what we're going to do, we're going to multiply both sides by 3.5. So we're going to get 7 here equals to x minus 30. And then we are going to add 30 to both sides, leaving us with x on the left-hand side. And we have 30 plus 7, which gives you 37. So 2 different ways, we get the exact same answer because our formula here is just the z-score formula rearranged. So whether we do it one way or the other, we will get the same answer. Last example, in example 2, it's saying Jordan achieved a z-score of 2.5 for a reading test. The state mean for the reading test, actually let's start highlighting. Z-score of 2.5. The state mean was 71.5 and the standard deviation was 6.4. Now, the first one is saying, explain the meaning of Jordan's z-score of 2.5. So let's think back to the normal distribution, okay? So you have your normal distribution. I'm just going to draw a rough picture of it. So normal distribution, we have our mean. We have 1 standard deviation above or below. We have 2 standard deviations above or below, and then 3 standard deviations. Now, as you get up to this sort of upper part of your normal distribution, the higher up you go, the better your score is, okay? Now, Jordan had a z-score of 2.5, okay? So in between 2 and 3. So his score is here. Now, relative to the normal distribution, this is a pretty high score, okay? He has scored 2.5 standard deviations above the mean, okay? So he's actually achieved quite an excellent score, okay? So all that it says, explain the meaning of his z-score. So Jordan has scored 2.5 standard deviations above the mean. Now, this is a great score. Because remember, not a lot of people get up here, okay? Just between -2 and +2, so below the score that he's got, 95% of people live within this range. He is above that range. He's on the upper section of this particular reading test, okay? So part B is saying, what mark did Jordan score on the reading test, and answer correct to the nearest whole number, okay? So we're just going to use our formula. So X equals to the mean plus Z times S. So score is the mean 71.5 plus the Z score 2.5 times 6.4. Okay, so this gives you 87.5, which is approximately 88. So he scored 88 on this actual reading test. So this is how we can find the score given the Z score, mean, and standard deviation from a particular data set. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.